Hello, everyone. This is Dr. Wen. What is the question here? We want to find the digit sum of a number. For example, the number is 1, 2, 3, 4, 5. What is the digit sum of this number? Which is defined as 1 plus 2 plus 3 plus 4 plus 5, which is 15. So we are going to develop an OR program to find this digit sum for any given number. Here is the OR window. By the way, OR language is a very powerful language in statistics, in data science, data mining, machine learning, and big data, and many fields. So now the program is what? To find the sum of all digits in a positive integer. Here is the OR coding. We discuss this algorithm through an example. Find the digit sum of this number. We already know that from previous page, the sum of this number equals 15. Right. What is the logic of this algorithm? First of all, we need to tell the computer what is this number. So here, we assign a number into the variable number. The number is 1, 2, 3, 4, 5. Tell the computer, run it. You can see number, we already give the number into the number. So here, let's check the value of the variable number. Here, what's the current value now? Current value you can see here. That's 1, 2, 3, 4, 5. Now, next thing, we need to initialize something to save all those digit values. We are going to collect one digit at a time backwards. That means we are going to collect 5 first, then collect 4, collect 3, collect 2, collect 1. So we initialize a variable called sum. Okay, sum, run it. Now you can see we already put 0 into sum because we don't have anything yet. The sum value, we can check it. That's 0. That's 0 here. So here, next thing we are going to do is find the last digit. What is the last digit? That's 5. Right? For the given 5, a given number, that's 5. So how to collect this 5? We use a concept from mathematics called a remainder of a number. So in all, we do have this function. So that's here. Let's use double percentage size. Now here, look at here. Given number divided by 10. So given this number, we know that 1, 2, 3, 4, 5 divided by 10. What's the remainder? It is not divisible by 10. You can see 5 is the remainder. So any number divided by 10, the possible remainders are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are remainders. That means that's the number. That's the last digit of this given number. So here we can see that we're given last digit, right? So here, run it. Okay, so now we want to see the remainder. We already saved to the last digit. If it is 5, it is 5. So the remainder is 5. Now we have the last digit value, 5. We need to save it into the variable sum. Sum here, sum. Updating sum. Sum originally that's 0. We put the last digit into sum. The sum should be what? 5. Right. So here we put last digit into sum. Let's check the current value of sum. If it is still 0. No, it is 5 now. We already put the 5 in. The next thing we are going to do is what? We already have the last digit. We want to remove it. We only have 4 digits left, 1, 2, 3, 4. We want to remove 5. How to remove 5 from that number? So in our language, we have a for function. We can use it to get rid of decimal part. Now, look at the example here. Decimal part. This is the for function. Now, look at the inside part. Number divided by 10. What does that mean? You can see here, that's the answer. Divide by 10, that means move decimal point to the left 1 digit. So this is no longer an integer, it's a decimal number. We want to remove the decimal part. So if we can remove the decimal part, the number will be 1, 2, 3, 4 without 5. That means we removed the last digit. So here, there's a function in R called for. In reality, any digit number, it is always in between 2 integers. One on the left, one on the right. What is the nearest integer on the left? That's called a floor. What is the nearest integer on the right? We call the ceiling in our language. So here, this will round it down this number into integer part, remove the decimal part. So now see this number, still that number, right? So we will get what we have here, 1, 2, 3, 4, right? This is a number without last digit. So here we save it into number. That means we are updating number. Original number is 1, 2, 3, 4, 5. Right now, if we run this, you will have a new value, 4 number. What is number here? Look at the number here. Should be 1, 2, 3, 4. Is that right? So we have done one iteration, right? We can repeat this on this number, 1, 2, 3, 4. Instead of 1, 2, 3, 4, 5, we can find the last digit 4. Then add this 4 into the sum. Then get rid of 4. Then we have a new number called 1, 2, 3. Repeat until this new number becomes 0. Then we stop, right? So here, stopping rule, we can do a loop. Stopping rule is based on what? If the number is 0, we stop to collect anything. So here, that's the loop. Why? Why do? Do what? There's a condition here, right? If this number bigger than 0, it is 0, we stop. this loop only works when this number is bigger than 0. So put everything together, we can create a OR function to calculate the digit sum of an integer. So here, what do we have discussed? That's a initialize the sum equal to 0, right? And collect the last digit, right? And put the last digit into sum. Updating the number, that means remove the last digit to have a new number. Then why this number is bigger than 0, we are repeating this procedure right here. When it becomes 0, then we stop. Then we have sum here. Return this sum. What is sum? Sum, we already collect all digit values and add them together. That's a sum. So we run this program. This function called a digit sum. Digit sum. And the input, that's a number. Run it, right? We have the program here. So now the number is 1, 2, 3, 4, 5. So if tell the computer said, okay, I'm giving number 1, 2, 3, 4, 5 here. So what is the digit sum? That's should be 15, right? That's return 15 here, right? Digit sum, just use this function, right? We know that. We already check it, right? 1, 2, 3, 4, 5. That's what. Sum equals 15, right? Sum equals 15. So we have the number here. If this number will change it to 1, 2, 3, 4, 5, 6, 7, 8, 9. So we run this. What's a new sum here? 45, right? So 45, that's the algorithm to calculate digit sum of a number. That's all. Thanks for watching. See you next time.